What does Grady Booch think of modern architecture and software development? Let's get into it. Hello, I'm Chris Dennis. I'm a KMP developer. Tech support's coming after that. Later, I'm going to continue on our with the watch along and comment slash rant with Grady Booch. I like Grady for the most part, but some of the stuff he says is a little crazy. I don't know. It's a little bit. He uses the definitions of words much differently than I think other people use them, or it's a little strange. So I've got some complaints. I'm gonna let him cook. I'm gonna let him cook. We're gonna go with part two. Here we go.
So just so I understand, because myself and most of us listening will have started our careers long after the Booch method was invented. For us, classes, variables, inheritance, that's pretty common, pretty everyday things. But as I understand, it wasn't like that back then, right? So could you talk us through what the environment, the technology was like? So that what made the Booch method so new, interesting, or innovative?
Well, let me go even further back to the 1950s and show you a parallel story. There was a time in the growth of algorithmic programming languages where the idea of a subroutine was considered controversial. Why? Because doing a function call added at least 2 or 3 more instructions, which was
Right. It's the same exact argument that C++ uses today. We have static variables and blah, blah, blah. Performance, right. When these machines were clunking along at half a megahertz, and we were like, oh my God, it's so much faster. Yes. Compared to writing it down or doing it by hand. Yes. Or adding a machine, you can do much more sophisticated things. Yes. But they always want to squeeze out the next little tiny thing. And it's like, yes, you can do that, but at what cost, right? And the cost is always like, we're gonna get it out today, but the cost is we can't maintain this shit now. Your code is a mess. Trying to change anything in this assembly language code with all this stuff everywhere, we can't do it, man. We got to have something else that helps us along. Like once you leave here, your knowledge of all this stuff, how it works, is gone. We can't ask you, and there's no way you can document all this stuff. It's changing too quickly. And then that's half the reason they want to like eke out the tiniest little piece of a performance out of it. Yes, because certain things are like that. But then all of the engineers think that's the most important thing, is because the people on the bleeding edge, they've been doing this. They've been squeezing out their little that's like the important things. Like that's not the important thing. The important thing, turns out, is this maintainability issue, this understandability issue, the extendability issue, the maintainability issue. It's causing everyone to go completely bonkers and insane, and people leave the industry because this problem is intractable. The way it's been set up and the way people promote it, like with his small scale sets of his MVP, it all works there great. But it's like when you have 500 people trying to put these things all together, it don't work so good, man.
computationally.
And this is the first time I've ever heard of the Booch method. I've been doing programming my whole life. I never heard of this thing. Maybe it's because I avoided the UML, because I was like, that doesn't smell right, man. And also I was, doing image processing stuff, and it's not this class of enterprise communications API level stuff. I wasn't doing that. I was loving this lower level stuff, so I wasn't really super interested. So I was able to skip it. But when I came back and with eyes of like an experienced eyes, like, what are you guys talking about exactly? And he's talking about those are UML. You can write the source code. It's like, I was like, I've heard this before. Seen these claims many, many, many times. I worked at a software company called Silicon Beach Software. We had a product called Supercard. There was a clone of HyperCard, and that was supposed to be like making a really simple language. It was just simplified, but it wasn't a simple language. It was general purpose computing. You could do everything you want on a Supercard and HyperCard that you could do in any other language, except there was more high level, right? So it allowed many more people that you would not expect to become programmers to use it. It was like a very simplified version of HTML and of JavaScript, but it was still super sophisticated. It allowed people an entryway to get on this thing, so we have more minds. And Apple, of course, killed it. they had the whole hypertext web-based stuff. All they had to do was make it not proprietary. But these guys, they can't stop with this proprietary stuff. They got to have their name associated with it, as opposed to saying like, this is a great idea, we're going to get to this anyway. It doesn't matter if my name's associated with it. I just want the ideas out there and promote the ideas. But he's like, look at the Booch method. No wonder I never heard of this Booch method. It's like nobody, like that was already, by the time you start promoting this Booch method from decomposing your program into these classes and objects, it was already like, dude, that's not the problem. Decomposing the problem is not the problem. How to extend this thing, how to decompose the problem so it's extendable and understandable. That was never even the part of it. It's like, now you're just decompose it. It's like, yeah, that's phase 1. And then we have phase 65, which is how do we communicate these ideas to people so they know how to implement these stuff and they understand how everything's put together so they can work in this ecosystem. Now just how do we decompose the problem first? It's like, okay, that's step 1. We're at step 55 now. It's like, we're way past that, man.
Expensive. So even function calls and decomposing something into subroutines was viewed as an architectural aberration, and people opposed it.
Yeah, because they were all running assembly language, and the machine hardware was not even capable of doing anywhere near what they were talking about. And yes, a function call made a big difference. When you're cranking through 1 million records, you got to do it in a week instead of 3 weeks. Yes, it becomes a problem.
Because it was inefficient. Well, obviously, we think, well, that was stupid because we need it for our management of complexity. The same thing, I think, was true back in the days of early object orientation. I mean, people were doing object orientation in algorithmic languages because you'd have these things in COBOL called, common data areas. People would devise, here's all this common data. And as a matter of practice, but not language, you would say, this data is used in this way by these algorithms and vice versa. In fact, going back to that project I mentioned to you at Vandenberg Air Force Base with those 32 computers, on the side of every one of those computers, every day, we'd see a printout of here is the common data pool. And so it was the abstractions right in your face because they changed. And so people were trying to do algorithmic or object-oriented decompositions, but the languages didn't support it. There was a need to do that kind of thing.
Right. Because, yes, you have to have a language that makes it easy, but you could do it before with assembly language. There's nothing stopping anybody from doing these things in this way. But the performance and the ideas behind it, so that the languages were to codify those ideas, not to make them the thing, but to codify the ways we're putting these things together, which is the Alan Kay stuff. It's the only way out of this is the Alan Kay way, the Kay style of things, where you have all these little objects that all talk to each other over very strict APIs. You just can't go in there because of performance. Make it faster. Like the machines are fast enough. We can start doing these abstractions now, in my opinion.
Until the languages came into play, there was no way to bring those ideas together efficiently.
Efficiently. Yes, there we go. There's the keyword, efficiently.
The Booch method was very much a reaction to the forces upon building software-intensive systems to look at classes, trying to apply it with modern languages and building a methodology around it. Today, we take it for granted because our languages make it easy for us to do this.
It's just fascinating to think back how...
Okay, the language might make it easy, but the thought process that goes into it to get people out of the idea that you have to go in and grab something because it's faster. Yes. Going into a sandwich making shop and getting behind the counter and put the sandwich together and then getting out and then charging yourself and then leaving the shop. Yes, it's going to be a lot faster doing that, of course. Making your own sandwiches is always going to be faster than going to a store and have someone else to make it for you.
Revolutionary it was, and compared to just how commonplace it is, and also to think about how things that we invent today.
It's commonplace, but it's bad commonplace. It's like people, this is the way it's done. It's like, no, it's just one of the ways we came up with back then. It's not the way it's done.
And that are revolutionary. In 20 years, people will be like, oh yeah, that's commonplace.
Yeah. Right, exactly.
One thing that you're known for, and
solving novel problems for humans in a way that makes them appreciate it. Who cares what we're using? It's like a hammer. It's like, yes, there was a time in the history when there was no screwdrivers, when there was no screws, and then all becomes standardized. Yes, and now we take screwdrivers for granted, but damn, are they useful? Still useful. It's like, oh, we just know about that. So there's this thing, this autist thing, because I have it too, of learning new things. I've been getting into cameras, and it's like every camera is the exact same thing, but it's all little variations different. And as programmers, we are attracted to that. We say, oh, you can solve this problem with this extensibility, usability, usefulness, understandability. We can solve that with a language. It's like, no, you can only solve that with philosophy. You can only solve that by thinking things through properly and trying in an evolutionary system where you're trying experiments, all kinds of experiments, to see if you're getting close to where you're going. Where's that part of the process? Is that part of the Booch protocol?
You also mentioned you're associated with it as UML. But can you share how this was created? What was the goal of it back then? Who were involved? And what was the need that it was solving at the time?
Right. So in 1982, two of my classmates from the Air Force Academy, Paul Levy and Mike Devlin, Paul had been a roommate of mine at the Air Force Academy. He was an economics major. Mike Devlin was a computer science major. Mike and I had a few classes together. The first time I ever met Mike was in an unarmed combat course, by the way. So not your typical thing you get at colleges, but hey, I was trained to be a warrior. That's where I first met Mike, and I think he
nothing wrong with that.
Out of me, if I'm not mistaken, in the pugil stick competition. But Mike and here I was at Vandenberg Air Force Base. Mike and Paul were
Oh, he's a boxer. Okay, that makes sense.
up in the Bay Area. They were working at the satellite control facility, and I engaged with them because they had one of the first largest ADA projects that was going on. So I went up and helped consult with that project. The two of them also went to Stanford, and I swear there's something in the water at Stanford, because they then connected with Art Rock and Hambrick and Quist, the two premier venture capitalists at the time. Art Rock and Hambrick and Quist were the key founders to Apple, and they also contributed to the funding of what became Rational Software. So in '82, Mike and Paul got together with me and said, let's start a company. And we did. It was a company called Rational Machines Incorporated, whose intent was to build a software development environment for this new coming ADA programming language. We saw that to be an opportunity
All right.
in which we could make piles of money. And we built
Oh, there we
hardware
go.
because
There's the real. So economics wasn't part of it, huh? Booch, you talked about at the beginning of this thing how economics has too much of an influence on computers, but you're talking about creating a company in a language to make money. This guy.
this was the time when, mini computers were becoming affordable. You had Sun coming into play here, but none of them were powerful enough to do the kinds of things that we were doing. So
well, there's always shit like that. You're always on the edge when you're trying to do something new with these things. Look, if we were paid to write the old software, we would be right. Okay, that's legacy of support. But even then, you're creating new stuff, right? We're never going to write the same software for the same people for the same problem. We've already written it.
Mike designed a system. I helped build a methodology around using the system. It was a system called the R1000, and that was the dominant ADA system used around the world for ADA at the time. Well, around, I don't know, would have been the early, jump ahead a decade now. Here we are, the mid 90s. And I was getting a little tired of doing that kind of stuff and branching out in other places. And I found that there was traction that I was getting from the Booch method into the commercial sector. I was giving a bunch of lectures at the time, and at one time, there was a gentleman in the audience who asked a really insightful question. And afterwards, he and I met up. A guy by the name of Bjarne Strustrup. And it turns out Bjarne
oh, God. So they did hook up. Ah, Jesus. No wonder. Because you were stealing his thunder with the ADA. You might have become a competitor, Mr. Booch, to Strustrup, who was trying to save his ass at IBM? No, he was at AT&T. He was at AT&T, and he is trying to save his bacon and make a name for himself and become famous and rock star. And you sees this guy coming up saying, "Hey, whoa! No, Ada's not gonna become the object-oriented monster. You gonna do C++? Oh yeah, let's do it. Okay, I'm so excited to hear what happens."
Thing called C with classes, which was the predecessor to C++. The two of us got together, we hit it off, we found that we were doing very similar things together.
Yeah.
And in fact, it led to the two of us doing a lecture series around the United States, where I got to know him quite well. And this was around the time he wrote his first book on C++. If you look at the
now I see what happened. These guys got in the marketing hype. And they had to get their sales thing, so they figured out their niches, and they weren't going to clash heads. One side's going to take this, one's going to take that. These guys.
References a lot of my ideas, and that's when my book on object-oriented design came out, and I reference his work a lot too. So, the Booch method and C++ kind of grew up together. Well, I thought this was interesting, and I remember a particularly important meeting I had with Mike and Paul around the time. It was at the Red Carpet Club of United Airlines in Denver. And they met with me and said, "Hey, Grady, we're thinking of moving the company in the direction of embedded systems." And I said to them, "Well, good for you. I think that's a stupid idea because you're missing the commercial sector. Go off and have fun. I'm going to do different things." That gave them pause. And I think they realized, wait a minute.
Shouldn't have said that, man. You shouldn't have said that. No wonder Strustrup became famous. You give them all best ideas.
Maybe there is something here in the commercial space. We were finding that we were having challenges continuing to grow the business in just the defense sector, which is what led them to that. And so they then made the decision, hey, let's take the Booch method and make it real. And that's what's the beginnings of a system called ROSE, Rational Object-Oriented Software Engineering, our first tool. The first prototype, by the way, I wrote in Smalltalk. It was a wonderful system. I wish I could.
Okay, so he knows about this stuff. So he knows that there's a way to produce this stuff. To produce software, what the Alan Kay was talking about. So he knows about it. But he's like, I get it, man. It's economics, right? It's economic sales, right? It's like, who's going to be your customer? Who's this for? What problem are you solving for them? What problem are they having? Which is this maintainability, extensibility, understandability, trying to bring a cog programmer in and just plug him into the system and he'll understand everything. Can we write something in a way that's more standardized? It's like, maybe. We can try. It was an iterative thing, man. It's experimental. It's like, does this work? We don't know 100%. If we did, we wouldn't have these issues. it would already be a solved issue. This one is not going away. This maintainability, extensibility, understandability issue is not going away. AI, this thing, whatever the current stuff is, machine language, guess the next word, AI, what they're calling it. I'm going to call it machine language, machine learning. That is helpful, but it ain't going to be the thing. It's still going to be a human
the source code for that around, but I
around to
remember
figure it out.
making changes to it just literal minutes before we did the first demo. And so
That's
that's
not
where we
uncommon.
sort of broke.
Is that? Do you think that's unusual, Mr. Booch? Do you not think that most demos that go? Do you think that most demos are set up and ready to go? We've been testing this baby for weeks. We got it nailed down to nothing, 100%, 100%. No! All these demos are done like the week, the night before, the day before, hours before. Come on, man. Sales, sales, sales.
Broke out from the defense sector into the commercial sector. And it was a big hit because that was the time when I think lots of others were recognizing object orientation was a good way of looking at the world, and C++ actually supported that.
It was one way to work with one set of problems. It wasn't like you were saying, it's the method to make all problems go away. Are you serious, dude? And you read Plato? You read the philosophers, and you think you have a way in a computer language to encompass all human problems? Sir, this is where the autists, they get all caught up in their brains. I'm a fellow at IBM. I have a language that covers all philosophical problems that may encounter in a human's lifetime. My name's Booch. I got the Booch method.
Well, that led to two things. Not just commercial success on our part, we began to make lots of money, and we began acquiring other companies.
You were making lots of money
during life cycle.
Can you just tell us what
Nothing wrong
rational
with that,
software
man.
did to this?
But I get where you're coming from, though. I get where you're coming from. Oh, I definitely get where you're coming from, buddy. Making lots of money, huh? Okay.
This
Sure.
commercial thing that was a
But it's not economic, right? A lot of these decisions that were made in software, Mr. Booch, was not made for economic reasons. He's pure. He's a software purist.
Yep. So rational software rose. Rational object-oriented software engineering was a personal productivity tool, if you will, that ran on an IBM PC. It also ran on, I think we eventually moved it to a number of other devices. It ran under Windows in the first one. That basically allowed you to, draw UML diagrams.
Oh, wow. So you could draw UML diagrams. Wow. So you've made a little special case draw program. Wow. Life-changing. It's a productivity tool, if you will.
UML, but Booch diagrams, so that you could then reason about and think about your design. We did a little bit of code generation, but really it was just.
See that? Oh, there was one. Oh, the code generation. You hear that, guys? We can go from UML to code generation, guys. We can skip the whole software developer. Look at that. We can skip a whole segment of problems. They want days off. They complain about the code quality. They say, I can't understand what's happening here. Do we have any documentation? They complain about documentation a lot. They want to know how other people came up with these ideas. Where did they come from? How does this thing work? We don't know. They're always complaining about that. We could just skip from going straight from the UML to the code. Yeah. Oh, that's not worth $1.
Design tool to help organizations think about their designs. And people use it quite well to document and specify and build their systems. Now,
do they use it very well? Is that what they're using it for, sir? I know of no one that uses this stuff. You promoted it. You made it sound like it was going to be the thing, but never really. People tried it, and guess what? It failed. So why don't you admit it failed? It's a bad idea. It doesn't work. Just having sketches of lines, boxes, circles. You could do the same thing without all the little details that people have to learn about your particular flavor system for your particular customers, for your particular use cases. Sir.
We started making lots of money off of it. And so we started acquiring companies. We bought a requirements company. Ed Jordan came to me and said, go look at these folks. We did. We bought a small company out of Cambridge called Pure Atria, which was led.
Oh, and you're not economically motivated?
By a gentleman by the name of Reed Hastings.
And these guys are just not that self-aware. I've only noticed this guy for what 30 minutes or so, and I've already caught him in a bunch of shit. He's just like, you're talking out the side of your neck, man. Like, what are you talking about, dude? You're a ivory tower way up above. So you have to demonstrate that this shit is working. And who are these companies? Do you have any studies? Do you have any case studies? No, it all works great. That's a wonderful thing, and everyone should use it, even though nobody does. It's like, okay, what problem are you solving? Diagrams? code generation from diagram? Is that what you're selling, sir? Okay, that was like a good selling point in 1992. Maybe people would have went for it back then, but people are kind of onto it now, sir. So why don't we have something else?
Reed came to us. We bought his company, and he said,
And we're talking about the founder of Netflix, right?
Yes. So we bought his
Small
company.
world.
Yeah, Reed
Oh, real
realized he's a
small world.
lousy CEO, and so he took his money.
All this stuff is open for disruption. By the way, I just want to say that out loud. These people who think they got it all wrapped up and got a code base. We got a code base that's just it can take anything. It can take any hit.
Around for a few years, figuring out what he was going to do, and actually that was a lot of the seed money that helped form Netflix. It is a small world in that regard. So at that time, at the peak of what we were doing, by the late 1990s, IBM Rational was sort of dominating the space of software engineering because we had tools across.
Yeah, it has nothing to do with like insider trading, consolidating, totally wiping out industries like graft to corruption. Like, no, it has nothing to do with that. It just happened to be around. Just happened to be around.
Every part of the development lifecycle. And this is where the ideas of incremental and iterative software development came into play. Long before today what we call continuous integration and continuous deployment. We were already doing that with a rational machine in our tools. We had pioneered those ideas.
Oh my God. You mean writing your code and deploying it into production? Oh, we're doing continuous integration, continuous management. Like, what are you talking about, dude? You're sending it up to an FTP server that's where people are running their code from, and they do an automatic update. Ooh.
Because we had built incremental compilation tools and the like.
See, they have these words around things that people are just doing normally for years and years and years. I mean, I was doing this stuff in the 80s, 70s, like not the 70s, but definitely the 80s. You download the thing, and you upload it for your friends or whatever, they run it, and then while they're not looking, you set it up, they run it, they log in, and they see your new thing. What? This is not... We're doing continuous integration, deployment.
So here we were in the 90s, and we had a whole set of tool sets around this. But because this was clearly gaining traction.
Oh, you have tool sets. It's like FTP?
In the marketplace, we weren't the only ones, and we were seeing the rise of hundreds, if not a few thousand companies that were beginning to try to do object-oriented kinds of things. And this was the beginning.
You guys are pushing this super hard. Oh my God, you guys! AT&T went in overdrive with this crap. They made it convinced everyone, just like the AI companies today, just like before that it was the blockchain. Before that it was, what was it called? Distributed microservices. There's been a whole series of these damn things. We're gonna revolutionize everything, and everybody just jumps onto it, realizes there's like 10% that's their core use case. They're super excited about it. We'll tell everybody else about it, but 90% are like, is this really supposed to solve our problems? Because it just created a whole bunch more.
Golden age of software engineering, where you had peak code and
golden age. Give me a break. We haven't seen the golden age of software engineering. This stuff is crap. This stuff is such garbage. Hold off. Oh, we're making billions of dollars, but closed source. Like, we're gonna hide on our knowledge, hold on knowledge, or we're gonna give you like certain things that go on a weird direction. It doesn't actually work for your use case. But we're like, well, work on all use cases. Like, no, it won't.
And Martin, we had Ivar Yakuson and Jim Rombaugh, and so it was a very vibrant time where organizations were trying to say, gosh, we've got these great tools.
Yeah, they're all gassed up because they thought they were gonna have their problem solved. They're gonna make billions of dollars, like you. Yeah, of course, they all come on the hype wave, man, before they figure out, oh shit, it's not what they said it was.
The ARPANET, we've got personal computers. How do we build software for it? So the presenting problem was in software, what is the best way to design systems using this very, very robust, very powerful set of tools we have at our hands? And so Rational being in a very interesting space, we said,
I remember all the programs coming out Rational that we all use daily now. What is this guy talking about? He's like a marketing machine. He is really high in his own supply. He markets the shit out of his own stuff, but it's not economic, guys.
We're kind of dominating the market. Let's keep going.
Pure software.
So we hired Jim Rumbaugh, and the task Jim and I had was to combine
pure software
methodology, OMT, object management technique, with mine. We were sort of the two leading.
Object management technique. Oh, he's got so much. He's got the Booth method. He's got object-oriented technique. Wow.
Ones at the time. And then we bought Ivar Yakuson's company because both Jim and I were using what was the idea of use cases. Again, talk about something.
The idea of use cases? You mean creating an object with one function in it that you call it? Wow, that's amazing. You guys are really cutting edge. It's like, dude, it's the wording of these things, and what people, when they first hear them, they're designing these words, because the freaking Uncle Bob talks about this. They're designing these acronyms and these words for sales. So people will glom onto them, say, oh, use case? What do you mean? I have a case of uses. I need to use things. And then they sell them this thing that don't quite work. And by the time you figure it out, they can blame it on you. It's like, oh, I just don't understand how use cases work. It's your problem.
Something that's part of the atmosphere. Use cases are just something to think about, but they were new at the time in the 90s. They were an idea invented.
Calling a function? Really? See, this stuff is like, it's just rampant in this software engineering. These people that have this run-on stuff, what's it called, gish galloping, like not explaining stuff, talking like acronyms, like things everybody understands. It's like, you have to just demonstrate all this stuff, sir. You have demonstrated none of it. Because if it was the real thing, we would be all using the Booch method. But it's not. But he's going to keep promoting it like he's going to sell it. Like, oh, yeah. It's like, dude, you're an IBM fellow. How about bring the honesty back? Bring some honesty back. Not the hype wave, the new thing, the one never been done before. Yes, it had, sir. They just called it something different. This stuff was been done before. Except the opening up, letting people access these black boxes and the applications instead of these walled gardens that we only have to pay monthly for. Come on.
By Ivar in his work primarily at Ericsson. And so we were working together with Ivar on building software for base stations for the burgeoning cellular telephone networks, which were a thing back at the time as well, too. So here we have the three of us who were brought together by Rational, and our task was, let's unify our methods. Now, you could never have found
Why? Just let's do it? Why? Why do we need to unify our methods? Any reason? Just nope, I want to unify the message. It's going to be the Booch method now, so I can promote this and use this as a case study so I can sell another course and a book and a lesson and be a double extra fellow at IBM. Like, what do you guys, like, this is so, like, this has been constant the whole time. This whole industry is rife with these kind of characters who just gish gallop and you just assume, wow, that sounds amazing, wow, it's incredible. But when you get into it, it's like, this doesn't really work like you said it was going to work. So what now, sir? It's like, well, you just didn't do it right.
Three very different people.
Same shit over
I'm
and over.
pretty amazed that we didn't end up with one of us in the hospital and one of us in jail. We were so very different. And I won't go.
Yeah. Now he just admits he does a little expose of himself there. He's a little bit on the, he's a little bit shisty, a little bit like you do. Like, he's definitely selling it.
Go into further detail on that, except to say,
I appreciate the game, man. I appreciate the game. Don't get me wrong. I'm in the middle of all this stuff too with everybody else, but I appreciate the hustle. I appreciate the game, but I'm like, I also get to call. That's my hustle, is to call this shit out. It's like, hey man, you guys got to demonstrate all of this shit that you guys are claiming just amazing stuff. It's like, oh, we just fight. Why? No reason. Just we're gonna go sales.
Except to say that
Acquire companies.
I'm very proud of what we created.
Lie, over exaggerate. Claims that are unverified, unknown, unavailable. Oh, you can go look into it. It'll take you 65 years to figure it out. By the time then, you'll be like, dude, this guy's full of shit. You're like, well, that was 65 years down the toilet. Go to figuring that out. It's like, this should be very plain. It should be upfront. It should be right there, right available. Here's all the case studies. Here's the way to do it. The reason you haven't been doing it this long, I don't know why, but here's all the things. Everyone that's tried it, every person has had all the success that we say that you have. No? None of that? Oh, okay.
And from that was born the UML. So we decided, this is not just ours. We need to make it something that the whole world could use. We made the decision to release it into the...
Oh, because all the goodness of his heart. Really? Is that the reason, sir? Not the sales, not the acquiring the companies, not the marketing strategies?
Object Management Group, and thus was born UML 1.0. I sort of drove...
Thus was born the sketchpad from hell. Here's the little diagrams. This is what this one means. This is what that one means. So this is gonna totally change your whole process.
Working with Jim and Ivar, I wrote the primary document for it. Obviously, it was the three of us working together. I don't want to, I want to give them complete credit, believe me. But after UML 1.0...
As long as they give you money, right? As long as you get paid.
I was emotionally exhausted and want to go off and do new things. So I kind of walked away from it at the time. I want to pause and mention one other person who was important here. Actually, two other people. The first was Philippe Kruchten. So we realized that our work was so big, we couldn't just do the methodology and the notation. So Jim, Ivar, and I worked on the notation.
The notation. See, there's also they're in this academic thing where there's this whole thing about getting a name made for yourself, and they got to come up with these methodologies and diagram things and like notations and shit. So it's stuff people are gonna do anyway. Look, I have a whole thing in my series, how to program from the ground up, talking about diagramming. Yes, it's very important, but having this UML crap and like all these different symbols, what they mean, what they do, and how that works, and how you put it together, you put this thing on this thing, you put this notation, put this, and this arrow means this arrow.
That was the UML. And
the fact of the matter is, every company is going to use UML differently. Every company who ever thought about using UML will use it differently, and they're going to use their own thing. They might use your tool, whatever, to sketch up, but they're going to deflect from your category of the notation and the code generation. They're not going to use it for that, man. If anything, but even then, there's a lot of people just let it go. Just a box, a line, a container, a line. We just talk about it, discuss it, and not trying to look at use the Gary Booch method.
Philippe worked primarily with some of Ivar's people on the methodology, and thus was born the rational unified process. Notice the unified.
Oh, the RUP. This is where this. Oh, okay. Now I get it. Now I understand. I didn't realize this is the guy that did the RUP. Okay. I mean, yes, there are some good ideas in RUP. Rational unified process or whatever the fuck. But it's not going to solve all your stupid development problems. Guys, this is the stuff that we've been dealing with because this academia has failed. The industry has like kept this stuff as trade secrets. A lot of stuff, how this stuff works, how to organize teams, how to organize projects, how to put things together, is a competitive environment advantage. Where if you know these things and you can shut up about them, you can go far ahead. Right? If you have a figure a way with your people, with your problem, with your thing, you can go acquire companies, get sales, make big money, make a name for yourself. Come on. And this guy's, oh no, economics drives too much of this. I'm Gary, man. I'm Grady Booch. We don't think about economics here. I'm acquiring companies. I'm doing this. I'm getting over here. I'm gonna name myself.
Philippe brought to the table a very important idea that we've begun to see.
Don't get me wrong. This is business in America. This is how we do it. I'm just calling it out.
Hints at with the Booch method, and that is looking at the world through multiple points of view.
Oh wow! Oh, the Booch method. Looking at things from multiple points of view. Wow, we never thought of that before. We're so grateful that Grady Booch is around to tell us to look at things from multiple points of view. Dude.
This idea of the 4+1 view model, which
the 4+1 view model. Oh, you don't know about? Oh, you're using only the 3+1? Well, we got the 4+1 over here. See all this like shit, this gish galloping stuff makes it's a hypnotic induction method. This is what they're doing in this market. He may not even be aware he's doing it, but he's trying to get you to come over and buy his stuff, man. Whatever he's selling. This is the method because it's like, what are you talking about? 4+1. What is that? And it's like you get this days, and now you're trying to listen to him closely. You're trying to follow along what he's talking about, but he's taking you off over this other thing, and he just dropped that last thing and goes on the next thing.
He grew from his work with building the Canadian Air Traffic Control System. Again, a very complex distributed system. Those ideas were eventually made manifest in IEEE IEC IOC standard 420020 on architectural description.
More gish galloping.
Which basically says if you're looking at an architecture, you have to.
Is that really what it says? Are we sure that's what it says? Or is this what you say it says?
To look at it from multiple points of view. Use cases.
Oh, so that's the IEEE standard, just to look at multiple points of view. Wow, we are so grateful to have Grady Booch tell us to look at the IEEE standard and go to multiple points of view, dude.
Logical view, process view, implementation view, and deployment view.
Oh
and
my
that's
God.
A very important and profound piece. The other thing,
it's important and profound. Really, it's so important and profound. What the fuck? This stuff is goofy as hell. Why people follow this? I understand why. It's because we're a desperate dearth of any information about how to structure these things and putting these projects together that can be completed on time and within a reasonable budget. And so people and humans can understand them. We can bring other people on the onboarding process so they can figure this stuff out and extend it without taking 17 months to figure out how this stuff works. Yes, that's important.
It came into play. Another person that came into play was Walker Royce. Now, Walker's an interesting guy. You talk about a small world.
Oh, he's an interesting guy, small world. Oh, it's not that you guys are on this circuit, this traffic. You're doing consulting, and you're saying you're gish galloping the fuck out of all these companies and making them seem like they're gonna get all their problems fixed, and they're just spending money on someone who just blows a lot of hot air. Like, what are you guys talking about? Like, all these projects. If there was a Grady Booch method, whatever, that solved all these problems, he would not be. He would be booked to his gills. But it's not. This is just a guy doing his good at self-promotion, which I respect the game.
His father, Win Royce, who I had the pleasure of working with when he was at Lockheed at the time, Winroyce was the gentleman who wrote
Defense
the paper on
contractor,
water.
defense contractor, defense contractor, defense contractor. There's unlimited funds, unlimited money, unlimited budget. Totally clueless. Totally idiots running the show, running the fucking park. And this guy's like, I'll come in and fix all your problems. I'll fix them all for $1. Defense contractors.
Fall life cycles. And his son was basically working on, spiral models in the Booch method. Wynn was misunderstood.
Oh my God! You mean experiment, figure out what happened, train, make changes, and then go do more stuff? A spiral and the Booch measured spiral. It's like, dude, this is common sense shit, man. But I guess he's just working with people who are so fucking stupid and so fucking like kiss ass and like, follow the rule. This is what the rule says. We do the rule. The rules rule. Do you have a rule for us? Oh, good. Oh, we have a method? You have a method. Woo. We like methods. That means we don't have to figure it out. We can just use your brain.
Because he was not endorsing waterfall methods. He said that's a stupid idea. In fact, look.
Okay, nobody said that he endorsed that. That's also, you should know this. Royce never said that. He never endorsed waterfall. He said this is the way people are doing it and it's bad. They never read page 2 of his book.
At Parnas's paper, A Rational Design Process, Why and How to Fake It. It's from that the rational software name came out of, by the way, which says at one level it looks like waterfall. Inside, no, it's what today we would call agile. So here we are.
Which is what? Which is what, sir? Agile just means flexible, which just means flexible. Nobody knows what this means. You're just talking like gift scalping these terms that you have a term for, but you have to also want to communicate with us what you want us to think it is. This stuff is ridiculous.
Here we are, the late 90s, early 2000. UML 1.0 was in the bag, and that was the life of Grady.
In the bag,
developers, we've all been there.
I mean, in the bank account, he got paid already for lying to people about how to fix their software.
With UML, we have the different boxes of different classes. We have the arrows between them. They describe relationships depending on the type of the arrow is. And when you look at this whole diagram, you get a sense of the structure of the software you're building.
Yeah, at a certain level. Okay, boxes and lines. What the fuck? Everybody's been using boxes and lines before UML, even before that stuff, man. And you're like, no, it's Gary Booch, it's UML, it's really important. We're going to do code generation.
So if you look at the very first line of the UML 1.0 standard, I believe it says something to the effect, the UML is a visual language intended to reason about, visualize, specify, and document the artifacts of a software-intensive system. It says nothing about it being a programming language. In fact, I voraciously pushed back against that. It was a
No, you didn't. No, you didn't, because that's what people immediately did with it. They immediately, and you had a program that you written at the code generation. So did you push against it, or did you implement code that did the thing that people really wanted to do? What they think was cut out the programmers, man. Cut out these goddamn programmers. Get rid of the programmers. We go from UML to code, and we're done.
Language meant to think about and reason about a system, to think about the world in object-oriented ways.
So we have to go through your way. So we do the Gary Booch flavoring of the boxes and lines to get to. So we got not only deal with our own problem, we now have to deal with the problem of the marketing and the sales pushing that Gary Booch has to say in his position has to do. I want to go through that. Not, hey man, there's boxes, there's lines. You can connect them together. You can put boxes inside of boxes. This is a way to communicate ideas with each other. There's nothing more than that. You're already doing it. Just remember to just keep doing it. There's nothing more deeper, and we're not going to do code generation. You cannot take a sketch and go to code generation. He did it. He implemented a system. He says, we're not. I pushed back on that. No, you didn't.
Particularly in ways that you looked at it through multiple points of view. DevOps today, by the way, is simply an amalgamation of deployment and implementation views. But we didn't call it back that way then. We looked at it from those kinds of views. And that's really where UML...
No. Oh, my God. All this stuff is just, these words are goofy.
1.0 was. It was meant to be, how do I think about these things? How do I reason about them? And
people were doing it before this crap. They were using lines and boxes with the boxes all the way before this stuff. I mean, we have those with process diagrams. I mean, what are you talking about? Oh, it's a class. Now as we're using classes and objects, it's much more different. It's like, dude, you're confusing the shit out of everybody and you're concentrating on the things that don't fucking matter.
I always intended for, you'd write a UML diagram and you throw most of them away. Now, unfortunately...
Yes, because they're garbage. Because they're garbage. Now, why are you throwing something away where you can put a sketch on a screen? What are you talking about, man? This guy's like living in the 1940s.
People didn't do that. And in the move from UML 1.0 to 2.0, there was a faction of individuals and companies who said, no, we want to make the UML very precise. We want to turn it into a programming language. And
because you told them you had limitations of this. Now, why did they want to turn it into a programming language? Why? Why would they want to do that? Just think about why do they want to go from UML sketches to code? To get rid of the programmers. Holy crap, this is not hard to figure out.
that was, I think, a profound mistake.
You're not going to get rid of the programmers. There's too many problems that the machine, you have to know about the machine, and you have to know about your problem space, and there's too much shit there to put into a fucking diagram. And even if you put it into a diagram, you're not going to be able to maintain the goddamn diagram.
I never intended the UML
So it's got to be something else
to be a programming language. But the net result of that was to make the UML much more complex, much larger. And the emphasis then was
to contain all the stuff you have to do for humans to get their problems solved in a general purpose way. You're going to do a language, man. You're going to have to write code like step by step, branch here, go back there. There's no way around it. You're going to have to do it. That's just the most efficient way to describe the problem. We've tried all these programming languages, makes pictures of everything. It just makes it more complicated than it really needs to be.
Upon not using it to reason, but to generate code and to reverse engineer. Now, the reverse engineering I can get. That makes a lot of sense. But turning into a programming language was a mistake. And I think that began
no shit, but everybody wants to do it. That's when UML died. UML was on the hype wave. When you were talking about how we could go from these diagrams to code, people were all about it. But when they found out that this shit don't scale, man. It does not scale at all. At all. That's when we were like, fuck this. And it was when it died, he was like, meh.
People were using it in the wrong ways. Its peak, the UML probably had
using it in the wrong ways, the ways you promoted? Dude, the people were talking about using, UML to code, UML to code. That was the whole thing. It was a major big deal.
30%, penetration in the market.
I remember that.
Which is
I do remember
cool
that.
If you think about it.
I was like, that don't make no sense because I've been using these graphics-oriented, picture-oriented tools when I was working at Supercard because we were trying to simplify. At that company, we were trying to simplify and make accessible these tools for anyone that wanted to use them to make them as accessible as possible. Turns out, people who really want to do this stuff are going to figure out a way to do it. That's really what we found out. It was like, and the people who aren't capable of it, they'll never be capable no matter how simplified you make the damn thing. They'll never get in there. They don't want to. They don't care. And we, as programmers, we forget that. People they don't give a fuck about these damn machines. They just got something else they want to do. They don't care how it's made underneath the fucking hood. They want to get it done. And we forget that this is how people are. They don't want to do the whole thing. They don't want to write the stuff. So we're always going to be in the loop. And that's just how it is.
And so I'm proud of looking at the systems in which it was used. But most of all, I'm proud of the fact that it helped people think of building software in different ways.
So when you say at its peak it had 20 to 30% usage, does this mean that about 20 to 30% of commercial developers were using it at the time? And what time was this? Around what time?
Yeah, here we're talking around 2000 plus or minus a few years.
I remember the hype wave coming through at that time, and I saw that. I was like, this is not what people think it's going to be. This is going to hit a scaling point real quick. And he says 20 to 30% of project. Now, sir, do you have any evidence of this? Do you have any studies? I mean, you're an IBM fellow. So if you're spitting facts and statistics, you better have some shit to back it up. You don't. Nobody cares anyway. It's over. Look, people want to use this AI stuff to replace programmers, and it's not going to happen with that either. You're still going to have someone who knows the limitations of the machine that most people don't want to learn about. And understandably, most people have other things they're trying to do with their lives, and they don't want to learn all the shit that we're fascinated by.
Remember that Microsoft was big in the midst of this as well, too, that they actually worked with us to take our Rose product and make it a part of Visual Studio. So we had a team that was working up in Seattle to make that happen. And it was a major selling point for Microsoft at the time.
Well, of course it was. Of course it was. Okay, I'm at the 40-minute part. Yes, people fucking hate code. Like, the managers want to get away from code. If they can figure a way to solve their problems without coding, they're going to do it, man. And I don't know what to tell you. Give you a like and subscribe, and I'll continue on part 3.